I should be better at using Zoom, but okay. Are we good to start?
Yes, Scott.
Okay. Hi, I'm Scott Sakai. I'm the senior security analyst at SDSC that's supporting HPC activities. Let's talk a little bit about running Jupyter notebooks securely on TSCC. But first is a little bit of terminology. There's this thing called a backdoor, and let's see if I can explain this concept using a video game called Link to the Past. So in the game, early on in the game, you have to go into the castle, and around the castle is a wall, there's a gate, and a guard. And the guard says, you know what, you're not allowed here, go home and go get some sleep, but you know you need to get into the castle. So how do you go about doing this? Well, if you go around the side, follow the wall, there's a hole in the ground, you go through the hole, and you'll end up on the other side of the gate. So you're going, Scott, what does this have to do with security? What does it have to do with backdoors? Well, the gate and the guard, that's kind of like SSH on TSCC. It's got encryption, it's got a curated password service, it keeps the bad people out and it keeps the people who shouldn't be there out. And then there's I'm sorry, this is slow responding. And then there's the hole in the ground that kind of bypasses all of that. And that's sort of like a Jupyter notebook. Now, that's not to say that Jupyter notebooks are bad. No, they're not. They're useful, and we want you to be running them. But we want to make sure that you use them safely and securely. So you want to cover that hole with something. In this case, the guard. All right, let's talk about the S word. No, the other S word, security. Now, why does it matter? You may be thinking, there's nothing interesting here, or nobody wants to attack me, right? But that's not quite the case. So let's address these points. There's nothing interesting here. There is definitely interesting stuff here. We have research of proprietary data, and the attackers, they may not know exactly what you have, but they'll just grab it all and then sift through it later and figure out how to monetize it. And then TSCC itself has a network identity. It's on campus, and since it's on campus, it may have access to things that an attacker doesn't have access to straight from the internet. It's also possible to use TSCC to attack other things besides campus, like another institution or a government facility or something like that. And it just hides the attacker's identity. The victim on the other side is going to see, oh, SDSC is attacking us. Wonderful. And the last one that's really big these days is CPU and GPU cycles. Yes, cryptocurrency, Bitcoin, Ethereum, that sort of thing. That is really lucrative because it's just straight real money at that point. And your return on investment is a lot better when you don't have to pay for the power. All right, so what about nobody wants to attack me? Yeah, you're probably right on that one. You're really unlikely to be targeted, but that doesn't mean nothing's going to happen. So you can still be a victim because most attacks involving an account, they're opportunistic. That's the wrong place at the wrong time. And yeah, true, there may be nothing interesting, but the attacker doesn't know that, so they're going to have to break in and then find out. Importantly, though, we don't know what their motives are. They may be up to something else. For example, they may be set on have a political motivation to go and destroy the trust in the research that you're doing, or they may want to just destroy or encrypt your data and then demand a large sum of money to get it back. This is also very lucrative and popular. All right, so let's talk about some real life experiences instead of this abstract stuff. Regarding TSCC, the internet is noisy. In the last 24 hours, I pulled up some logs, and we've had 2.5 million SSH login attempts with an invalid name, username, and password. So those didn't succeed. Those all failed, and that's 2.5 million. And then also we've had over 10,000 connection attempts to the default Jupyter Notebook port. That's 8888. Most of them didn't succeed because there was nothing there, but some people were running notebooks. Hopefully after this talk, that won't be happening. And sometimes they get in. Here is a real incident that happens. we got a ticket, and a user says, hey, there's some strange files in my home directory, and I didn't put them there. Uh-oh. All right, so I get, as the security person, I get to go and figure out what happened. So I got questions and answers, and they lead to hopefully piecing the pieces of the puzzle together to figure out what happened. So the first question: where were the files created? When were the files created? Oh, by the way, I already deleted them. Great. By the way, if this happens to you, don't delete the files until we say to, because we might need those. Fortunately, in our case, we had snapshots with the files, and we're off. So when were the files created? It's a very specific time. Let's call it T, because I don't want to give actual dates and times. Was the account logged into around that time? Yes, it was. From a foreign IP, great. And it was using an SSH key, which is kind of strange because usually it's a compromised password. So we gotta dig a little bit deeper. Were there any new SSH keys added? Well, no, there was only one. And are there any SSH keys in the account's home directory? Unfortunately, yes. And when was that SSH key file last accessed? Just before T. So there's a strong chance that this SSH key file is related to the intrusion. All right, so big question: is there a passphrase on that file on that SSH key? Unfortunately, not. It's not the user's fault. This was one of those things that just happens automatically. If you know the person who started the idea that we should just generate SSH keys for all the users and put no passwords on it, I want to have words with you. Okay, so let's continue putting this puzzle back together. What else is going around on time T from the host app, that foreign IP? And we saw connections to port 8888 just before that time T. Well, okay, so now we know what happened. The attacker found a Jupyter notebook, and it wasn't protected, so they just hopped right on in and retrieved the SSH key that had no passphrase from the account's home directory, loaded it up on their client, and then hopped right into TSCC, logged into the account using the key, installed their crypto miner software, and then when the user came in and started looking around, they said, hey, I don't remember putting this there. Okay, let's take a break and talk about TSCC's architecture for a moment. Here's a diagram that we're going to be referring back to quite a bit. We have a bunch of compute nodes that comprise a TSCC cluster. There's a login node, and then internal network, and then an external or public network where the compute nodes and the login nodes are attached to the internet. And then, of course, there's a user who is also attached to the internet. And do you have any questions? I see there's one in the chat. Yes, thanks. All right. Going in 3, 2, 1. All right. Get rid of the chat. How do I get rid of the chat? All right. How to use Jupyter notebooks insecurely? Well, the first way is don't set a password or use a weak password. If you're using UCSD Tritons as your password, you might want to fix that. Remember, as I said before, TSCC is always being probed. That those 10,000 connections per day, yeah, it's constant. So if there is a notebook running and it's exposed to the internet, it will be found. It's just a matter of time, and if that password is gone or it's a weak password, those people will find it. Here's an example of what it looks like when you're setting up a notebook and you disable the password. So you have this Jupyter notebook password, enter password, hit enter twice. Okay, well, there's no password, so it should be easy to access. You don't have to forget this or type in the wrong password or that sort of stuff. So you start the notebook up, and then I'm going to go over to my browser and then load the host or put in the host that's running the notebook. And surprise password prompt, let's just hit enter, and then done. So you're probably wondering, how hard is it to find a notebook? Well, it turns out it's not that hard. Here's the attacker view. We're taking the role of the attacker here, and we're going to use a tool called ZMap to just scan the entire network that this demo server is on. There's 256 hosts, and you'll see that almost instantly it found one candidate, and then within a couple seconds later, we're done scanning. So fortunately, there is only one, which is what I expected. Now, as the attacker, you don't know what's there, so throw it in a web browser and see what happens. And oh look, it's a Jupyter notebook, and let's try no password, and surprise, we're in. So yeah, in less than a couple of minutes, we've discovered a Jupyter notebook and gotten access to some person's account. That's not a good thing. All right, so let's refer back to this diagram. And what you've noticed is that we've been interacting directly with the Jupyter notebook that's running on the compute node. And it's plain text HTTP or HTTPS with an untrusted cert. And, yeah, that's kind of insecure. And we're going to talk about why that's insecure. But first, I also need to, talk about why that's insecure. So plain text HTTP means that there's no encryption, and all of the data for the website, the cookies, the headers, the actual payloads, the things that you're typing in, all of that is flying over the network, over the internet, and sometimes broadcasted in the air without any protection against being viewed or altered by a third party. So what this means is an attacker can capture your passwords, and an attacker can capture the cookies, which bypass passwords. And we're gonna do a demo of that attack right now. So before we go into that, we need to talk about another concept or terminology called the man-in-the-middle attack. You may also find it referred to as person in the middle or monster in the middle. But even though times are changing, you'll still see see this terminology as the most common. So for this scenario, there's a local network like your home or a cafe or a hotel, the airport, that has some sort of network infrastructure that's attached to the internet, and then a user who's soon to become a victim that connects to this network, and then they go through the network to the internet and then to the TSCC, and they're accessing their notebook over HTTP. So now we introduce the bad actor, a monster. In this case, it's a cat, angry cat. And they're going to do something to the user who's now going to become the victim. And we're not going to go into detail as to what that something is. Think of it as a magical spell. And what it's going to do is it's going to cause a victim to send all of its network traffic to the attacker, and then the attacker will take a look at it and then forward it on to the rest of the to its final destination. And so now that HTTP traffic is going through the attacker's control, and they can look at it and change it at their will. All right, demo time. So here's what the victim's experience is going to look like. So they're running a Jupyter notebook. They've said, okay, we're going to just let Jupyter generate the password or generate a token, so that's secure. And then it's running in the process of just cleaning up the token because I'm going to need that. And yes, I know that there's a no browser argument, but I didn't know about that till after I recorded all of this. So here we go. Log in, paste in the super strong token, and we're in. Now, unbeknownst to the victim, the attacker has already been monitoring their communications, and this is the view that the attacker sees. This program here is going to record or show all of the packets or network traffic that's crossing the network as the victim is doing stuff. So here we see that it looks pretty human readable, and that's because it's plain text, it's not encrypted. So let's see if we can grab a cookie. We're gonna look for a cookie, hit the reload button, and then boom, right there, that's the cookie. We don't need the victim's view anymore. And what we're gonna do is take this cookie and load it into a web browser that has no existing relationship with this notebook. So you see, we try to log in, it goes past the token. Well, yeah, we don't need either of those. This is a standard Firefox install. There's nothing special about it. Use the developer tools, insert, create a new cookie, paste the cookie name. Might actually go faster. And then grab the value for that cookie and stick that value in. And then if all goes well, once that cookie has been committed into the browser and you hit the reload button, then we're in. And it kind of looks like that. So HTTP plain text, it is dangerous. So what have we learned? Well, SSL is definitely essential. However, a browser trusted certificate is also essential. So you see that little warning over there on the side. You may have seen that before, and you're like, oh, I don't need to deal with this. Let's just continue to the web page. Well, the attack that we just saw still works if the certificate warning is ignored. And you're wondering, like, well, how does that work? It's SSL, right? Well, almost. So the victim talks SSL or HTTPS to the attacker, and then the attacker has a completely separate SSH connection, or sorry, SSL connection to the notebook. And then in between, the attacker just looks at the plain text and then shuffles it from one side to the other, back and forth, and then reads and copies as necessary. All right, so questions. I see that there's 3 items in the chat, and we'll talk about how to use Jupyter Notebooks securely. Okay. All right, any questions? Going in 3, 2, 1. Okay. All right, so how do we use Jupyter Notebooks securely, not insecurely? So we've learned set a long password, or better yet, just use the auto-generated token. And then we need to keep the notebook off of the internet if at all possible. If it's not on the internet, it can't be probed from the internet and it can't be attacked, at least not easily. And then encryption or HTTPS or SSL or TLS, that they're all the same thing. It's important over unfriendly networks. And just so you know, the internet is unfriendly, but so is most Wi-Fi networks, including the one at your home. Well, we already dealt with the first one. Let's take a look at the second item. Launch the notebook in a way that prevents it from being directly reachable from the internet. Ugh. So Jupyter Notebook command, you already know that there is an IP argument, because otherwise you would just bind to the loopback interface and you wouldn't be able to access it. So when you're running on TSCC, there's an internal network, that internal network that we saw in the diagram. Use that as the IP, and we can quite easily get it by just taking the short host name and adding .local to the end. And that little snippet at the bottom is how you would do that. And now let's tackle this encryption issue. So yeah, it's difficult. If everything is done right, we've got this Jupyter notebook that's running on a compute node and it's not reachable from the internet. So you're gonna have to do something to get to it over the internal network. And you gotta go to the internet to the login node, from the log node, bounce through the internal network to the notebook. And the prevailing wisdom for this activity is, for this task, is to use an SSH tunnel. And you tunnel from your client to the login node, and then the login node kind of opens a connection for you to the Jupyter notebook. It's a really poor user experience, and I don't want to talk about it because it hurts. I don't want to put anyone through that trouble. So what we did instead was we said, okay, let's come up with something else. We developed this service called the satellite reverse proxy. It's self-service, meaning that the administrators don't need to be around in order for it to work. It speaks plain text HTTP over the internal network to the Jupyter notebook, and HTTPS with a trusted cert over the internet to the user. And the self-service process looks kind of like this. You or a script will grab a token using curl or wget, stick it somewhere safe, and submit the job. The job waits as normal. And then when the job runs, it'll start the service, like the Jupyter Notebook or any other web service for that matter. And once it learns the port, then it'll take the port and the token and redeem it. And then the request from the host that, the IP of the host that's making the request plus the port plus the token gives satellite enough information to create a reverse proxy entry. And then what that means is that the notebook will appear at a very specific and unique URL, and all requests from the web to that URL from that web browser will be forwarded to that that host and port when the token was redeemed. And after some time, it just goes away. Here is a just manual. Here's an example of doing this manually, just so you can see the various moving parts. This was done on Expanse, not TSCC, but the process looks very similar. So here we've grabbed a token. That token becomes part of the URL with HTTPS. We just stick that on, and instead of Expanse user content, it's going to be TSCC user content. And you can see there's a page there. It's all ready to go. And if this was a job that was sitting in the batch queue, you could just sit on this page until that job runs. Here we're taking a look at what our test job is going to look like. It's going to listen on port 65432 and pretend to be a web server for 10 requests or so. And when it runs, it starts a web server and then redeems a token. So let's go ahead and save that token in a. Let's go ahead and save that token in a environment variable and submit the job. Here we're using srun. You're going to be using qsub because different system. Expanse uses slurm, TSCC uses torque. Here we go. And then it immediately gets run. The token has been redeemed. And this job is now running on some host, some compute node. We don't know what it is. We don't care what it is. And then as you see over there on the web browser, there's some progress going. And it may take a minute or two for that final proxy entry to be created and the page to show up. And in this case, it actually does. And rather than speed it up, I just decided to let it run for real time to give you an idea of what it feels like. And that little bar goes back and forth. But yeah, it shouldn't take more than a couple minutes once you got into the map state. Okay. I don't want to start singing, so hurry up. And there you go. So now we see the content that's being served by this web server that's running on some random compute node. And web server is done. And now the service is unavailable. Because the web server is gone, the proxy mapping is still there, and the satellite's going, well, there's nothing accepting this connection. That's why you see that. Okay, so let's talk about some parting thoughts before we move on. Remember, there's more to security than this presentation. I have a somewhat longer webinar from last year that covers more topics that are still extremely relevant to HPC. Hey, did you back up your data? If you didn't, this is as good a time as any to do that. As I said before, there are people out there who will go and take your data and encrypt it and then demand large amounts of money. And UCOP has said they're going to stop paying that out. So make your backups before you need them. Patch everything. That's the machine that you're using. That's the machine you're using. The software on that machine, and even the environment, your Python environment. Python modules get security updates too. In fact, Jupyter Notebook just got one. And protect your account to protect your research. As we said, there's all kinds of people out there who have different motives. And the last thing we want is to have your research invalidated or called into question because the integrity of your account is called into question. And finally, if you do everything right, you may still be a victim of a cyber attack. And it's an accident. It can happen, and it's not your fault. That's important to know. It's not your fault. So if something like this happens, such as like that, the user who came to us and said, hey, I have files that I don't remember putting there, yeah, just come and reach out to us and we'll sort it out. We're not here to put blame. We're here to figure out what happened, and if something bad happened, keep it from happening again. All right, so last questions before I hand up to Marty. Anything else? No questions?
All right, thanks, Scott.
Okay.
What Marty's going to talk about